Does it matter if those loops are shorted together? Does that make any difference, or if they're separated, or maybe I'm misunderstanding something about how this works actually?
You mean the ends of the coils?
Yeah, where you have these apparent vertexes of the loops where they go inward.
Mm-hmm.
I know they look like they're shorted together.
I kind of like to make them so they didn't short out at all, and you could run current through them. I mean, you can still run current through them, and they have some effects, but I really don't think it matters if you short them out, because you're not really running current through them. The current that runs through them naturally runs through them and takes the easiest path, which is going to be along the wire itself, and it's not going to want to short out.
Okay, maybe I'm misunderstanding. It's not for harvesting electricity, is it?
No, it's not for harvesting. I mean, John Fiala here is great at harvesting electromagnetic fields and ambient energy and stuff like that. This is just harvesting a little bit of the ether energy in the
Okay,
material.
so I'm glad you made that distinction then. Is that just aluminum solder that you're using?
Yep, aluminum and tin and lead, and/or aluminum.
Thank
Did you want to talk about energy harvesting, or?
Yeah,
Before I ask
this is probably a good time to dive
Okay.
in on that. You know, there's subtle fields or weak fields, and there's strong fields, EM fields. As we mentioned earlier, anytime you have a EM field that passes over anything that's conductive, whether it's ferromagnetic or not, you generate a current, electron flow. And those big things that, when you're in school, you had that little bar magnet and you laid the sheet of typing paper on it and you sprinkled the iron filings and you get those, what do they call those lines of? Magnetic flux, that's what it was.
Mm-hmm.
And you know what? Every time you cut a conductor with 10,000 lines of flux, you get 1 volt amp or 1 watt. Okay, John, that's really great. That's basic electronics. I learned that in elementary school. Thank you. Okay, how does that play here? Well, sometimes, we were talking about, somebody asked a question about healing fields. All the molecular structures in your body are polar. Sometimes when you have blood vessels that are not flowing very well, you can excite them and get them flowing again. The flow of blood and oxygen increases. You have stored toxins, heavy metals, you can release them. We were looking at the plants, the 2 jars there. You can take an EM field that is sympathetic to the organic structure that you're working with and increase the flow the same way we just talked about the flow of blood and oxygen, nutrients, to the, maybe the dermal or subdermal tissues damaged, but we increase in that plant, we can cause the sap, and the nutrients to run better. All of a sudden the plant grows better. Now, wait a minute. We talked about energy harvesting a little bit ago, didn't we? You used that word. Did he use that word? Did he say that out loud?
I did.
Yeah, he did. Oh, okay. The easiest energy field to harvest is one that's moving. One that's stationary, where the lines of flux are stationary, is that moving along a conductor and cutting lines of flux? That's kind of hard to harvest that, isn't it? But if it's a moving field, if there's anything moving about it, you can, just like a bicycle pump or a well pump, that's got you can put a check valve on this end and a check valve on that end, and you can get it to flow and stay. You pushed it out through the check valve and it stayed there, and and when you came back, it didn't suck it back in; it drew in some more. Well, part of the problems with harvesting a lot of energy is that check valve or the diode rectifier. Some of them, like if you take a bicycle pump and you short stroke it, and you're trying to pump up 32 psi in your bicycle and you're at 26, but you're sitting there pumping and short stroking, maybe doing there's a lot of energy going on there, but are we actually getting anything into the inner tube or the tire? We haven't reached the point where the check valve, comes off its seat and you have to go full stroke. Well, on some of those to actually begin to harvest, some of that energy that, we're putting on a lot of sweat, a lot of effort, but nothing's getting done. It's a whole lot of work going down, But So, oh, wait a minute, John, we need a better rectifier. Good question. Good. I'm glad you told me that. Thank you. There's companies like NTE out there that are developing high-speed switching rectifiers with low current gates, low voltage gates, and like Linear Technologies has a chip now they call an energy harvesting chip. As of about 2.5 years ago, John Arthur, showed off one on an evening thing about a few years back, and last year or 2 years ago we talked about the energy harvesting chip. But what it does is that the subtle fields that a conductor, wait a minute, is an antenna a conductor? A monopole? It is, isn't it? EM fields passing through there. We could take a monopole and, and it could, if we have something, it's a subtle field, but if we have something that can capture the back and forth, the fluctuations, and we can pump that circuit up, and get it to flow through the rectifiers and charge a capacitor, then we can harvest it. So it's all about the check valve and the storage battery. In this case, we use capacitor. Now, there's a lot of EM fields out there that, like David said earlier, we haven't really mapped them all out like the
subtle energy fields or ether fields.
Like and right now the ether is one of the terms that it's one of the things we use to apply to a lot of and there are some people that, because they know it's there, they see it, they've got something coming out of it, but they don't know where it's coming from. So there's a lot of folks, very honorable, very upright, they just throw it in the category of the ether. The true definition of the ether, well, I guess we've yet to come to that, haven't we? It's kind of that's kind of a broad term right now. But see, that's the exciting part. And some of these that not only harvest or interact with an EM field, but harvest, and when I say harvest, and potentially do what? Focus it? Where's the mouse? RGB1 on the, okay, thank you. We got to go back in the presentation.
Yeah, I got a little more to do
here. Yeah, I know. Go and then select the video selector to A, please. And now, I'm going to back up here, and I'm hoping I'm not stealing some of his thunder, because here we are. Oh, yes. Okay, look at that. Where's the magic pointer thingy-do-jobber here? Is that the, okay. Now, look at that. We have something, does that look like an antenna? Now, we all know that different antennas interact with different EM fields. And the structures that, monopole, dipole, Yagis, I'm an antenna theory fanatic, I'm on the 12-step program. I'm on the first step. I've admitted I'm a recovering fanatical scientist, a researcher. I've never got past the first step. I can just admit it, that's all our father I got. But look at this. Is that, okay, collecting?
I do want to mention that these are bent down 72 degrees. I didn't say that in my construction. These first coils are designed to catch the incoming waves, the right, left, and then the secondary 3 coils are bent up 72 degrees totally. So that's something I just want to get on record, so people making these know. You have to bend them down by hand after you've made them. And again, use the 3, 1, 1, 5, 6, 12, 1 bending ratio when you do it. And that would be the final construct to this antenna.
Yeah. So the control group here and the treatment group, we've got the collector and the emitter. It's harvesting it and focusing it, okay? Now, some of these EM fields, how many electrical engineers do we have in the crowd? Anybody that's a radio engineer? Anybody got FCC licenses or radio? Okay. the size and type of antenna, if you have a communication or some little data burst of energy that you're trying to send, how critical is having the antenna the right length or the right, how important is the design and size of the antenna for what you're trying to receive? Very important. It's actually the name of the game, isn't it? It's the whole shooting match, not just part of it. So there's all kinds of strong fields, weak fields out there that we're learning how to capture. And as strange as it sounds, the energy sometimes that comes back out of it, now let me see. There's
It's true, John. Some of these, the bigger ones I make, they don't work very well. Sometimes the smaller ones work better because I think they resonate with the shape of the wave better.
Have you ever tried to tune a monopole?
Crapshoot.
Have you ever tried to tune a monopole by resizing it? Just a regular straight up antenna? Yeah, vertical antenna. How do we tune it? We change the size, don't we? You know what? How do you tune a shortwave antenna? Change the length, right? Okay, change the size, change the length, and it receives that specific frequency better, okay? And you can harvest better by changing the size of the antenna and the configuration. Well, that's what this is doing, except when we're looking at this right here, like we were talking about the human body, well, that's just a biological organism, isn't it? Oh, wait a minute, those are biological organisms also. Oh, the molecular structures are polar in them too. Imagine that. And we figured out a way to collect some energy, excite the natural, which is already going on, and cause it to increase the strength and productivity there. So what's happening is that are we inventing something new? No, we're just making what's already there work better, okay? And some of those who went to the 2010 ET, you probably remember there was a thing that I got a hole in me. I was the dubious recipient of a misfire on a mortar round at a demonstration, and something picked me up, tossed me about 8 or 10 feet, and set me on fire, and my clothes, and I kind of looked a little bit like Al Jolson, and I had this big hole in me, and they said it was going to take quite a few plastic surgeries in a minimum 18 to 24 months. And if you go get Jamie Butereff's DVD from 2010, you'll see, and there's also one 432 megahertz healing on YouTube. And Jamie actually put up the little clip, but that was all electromagnetic healing. And,
Yeah, let me finish up with these.
more of the rodent.
Yeah, well, this is sort of a coil that's it's along the rodent coil parameters, but I did want to mention these fractal patterns that I was talking about earlier can not only be used for sanding mirrors and symbols, but you can make magnetic windings out of them. So you take a piece of copper wire and wind it 3 times on one side, once on the other, then once on this side, then 5 on here, and then 6 on here, and then 12 on here, and then 1 on here. And again, it makes those, what did you call those fields? Bifilar fields. Yeah, it creates bifilar fields. And I've had some wild results with magnetic windings.
Yeah.
Some of them I haven't been able to repeat, but some of them I have. One time I think I saw some ether actually pile up on the end of a magnetic winding, and it looked like transparent, glistening honey almost, kind of, like translucent honey. You could see right through it, but it kind of was iridescent. It dripped off the end of the winding, hit the floor, and it actually oxidized the floor where it hit the floor. And other weird, experiences like that. So I think you can also capture the ether with magnetic windings. I really haven't gone into that deeply because I'm a little embarrassed talking about experiments I haven't been able to repeat. But if anybody wants to get into this, I would suggest magnetic windings is a great potential, as well as, the ether coil, make windings using these patterns. And
show them one of the other coils you have. Don't you have another coil?
Yeah, this is another coil. And if John's done, when he's done, I want to take you all outside and throw these mirrors in a bucket of water, run a little current through them, and see if there's any photon resonance.
After the session's over, we're going to go, we'll set up a pop-up outside, and we've got a little tray of water out there, and we're going to maybe play with some salt and some crystals and
I'll skip the
just
salt. That
tinker a
didn't
little
work
bit.
at all yesterday.
And
so.
maybe some optical refraction to see
Yeah,
what...
the optical refraction
I
might
don't
work
know,
today. Maybe if the sun's a little lower, it might work better. And just so everybody knows, I'm looking for financial backing for research into this work. I've done all Mr. Wizard experiments as best as I can, and I really could use some serious money and equipment to pursue this research, because I think there's anti-gravity potential, free energy potential,
Well, the
healing
three-axis
potential,
field, yeah.
even, dare I say, interdimensional travel and communication faster than light potential. So, but it just would take a little bit of backing and a small amount of real lab equipment to get started and get going. So I am unshy in asking for my financial backing.
Today there are a lot of researchers that have seen something that they can't explain with words, but they know exist. Remember Einstein, he understood relativity and special relativity cognitively, but he couldn't put it into words, and there are some people, psychologists, that'll classify that, excuse me, John, that's a right brain, left brain thing, and it's like the women see everything as a holistic picture. They can see 5 apples laying there, and they don't have to go 1 + 1 + 1. They just see it, and they say 5. The men say 1 + 1 + 2, 3, 4, and they count them. But Elsa, his first wife, had the math background. She was the one that was able to prove that what he already saw was real. There's a lot of researchers, and us in our daily lives. Have you ever seen something or felt something that, I know there's something there, and it's powerful.
Actually, John, can I put the math on? I got 1 page of math here.
Yeah. Let's
for the record.
go back to RGB 1 and A, please. Okay. There should be.
Let me just show some math at the very end here that I didn't work this all out by myself. My good buddy who's back east and in ill health right now helped me. And he was really the brains behind a lot of this math. Here's a little more math that science needs to incorporate. We were taught in school, just getting back to this presentation real quick, that at 5 to 9 you round up, and from 4 to 1 you round down. And when you hit 0, you do nothing. But as I discussed earlier, 0 is just a probability envelope. It's looking at something and saying, we can't see anything, so we'll call it absolute nothing. But we know darn well, in reality, there's something there that is too small to be observed, so we call it 0. So the way numbers should be rounded off is 5 to 9 up, 4 to 0 down. That'll give you much more accurate mathematical results. And that is the scientific way to round off numbers. Our number system was created by merchants to calculate money flow. And they figured out how to round off numbers, not scientists. So this would be the scientific way to do it. And this is really some Einsteinian math we worked out. E equals mc to c to phi squared. This is phi times phi, which is 2.618. And that is the, what is that? That's pi to the 13th, which is the speed of light times gravity equals that number at the very far bottom there, pi to the 13th, which is a little more than coincidence, I think. I think that can be, I'm not sure what it means, but I think that can be maneuvered into modern science very easily. I think it describes the shape of the universe. And E equals mc to phi squared, not just c squared, but phi squared, which is, instead of c to the second, it would be c to the 2.618, and equals mc to phi squared there. Okay, you got that. And so that would mean that, it's not just E equals mc squared. The photons don't go along and then split. That would be squared. They go along and split, and each one twists a different direction. That's where the phi comes into the c squared equation. And all numbers are fractal. Every number goes on forever. There is no round number. 1 equals 1.1111. 2 equals 2.2222. So all real measurements are fractal. They go on forever. They don't end in 0, or they don't end. They keep going on. Even though you may not be able to see anything down there for a long time, they continue on. So if you fractate all your numbers you take you have 3 as an observation and you turn it into 3.333. If you take all your data and fractate it and make them fractal numbers, do your calculations, and then unfractate it, boil them back down to the original unit number, if you will, unit data number, the results will be a little different but more accurate than ever. The universe resonates in 7. This has to do with the spikes in the spiral. It goes in, piles up, backs up a little bit, goes in again, backs up a little bit. So it takes 4 steps. This is what time does. It takes 4 steps forward, 3 steps back. 4 steps forward, 3 steps back. So that's the way time actually works at 600 billion times a second. And we'll skip that one. And this is just to say quantum entanglement is actually the 2 particles never leave each other. The universe implodes in between them. So when 2 particles split, they're really standing still. Space-time rushes in between them. And that's the end of my presentation. I would like to take everybody outside.
And if anybody has ever just had the frustrating feeling that you've never seen energy from the ether, well, tonight or today we're going to resolve that. And you can no longer say that you've never seen energy from the ether.
Kabloom.
Yeah. Energy from the ether. David Garraway, thank you, ladies and gentlemen.
Thank you. Pleasure being here. And
Okay,
I hope you'll all
now-
accompany me outside for a last-minute attempted experiment, an attempted demo.
It's going to take us about 3 to 5 minutes to get set up out there. How about if we have them be there in 10?
Okay.
That'll give
I
you
hope you'll
time
come out and give it a shot.
to take your comfort if you need to, get some soda or something to drink, and then we're going to meet.